Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us to stay curious. Today, we've got two employees of Vaya Space right here next to me, Rick Powis. Rick, great to meet you.
Nice to meet you.
All right, and Josh Dzugen. Josh, good to see you.
Good to see you again.
They both are electrical engineers at our hometown rocket company. Literally about 30 miles from where we're sitting in downtown Titusville is Cocoa, Florida, and you have some offices off the Gus Grissom Parkway, if it would be up there.
Yep.
And so, how's the hamburgers at the Pint and Pistol there?
They're pretty good.
They're pretty good.
They're pretty good.
That's one of the restaurants in front of them. It's a fabulous shooting range,
Oh,
too,
yeah.
by the way,
Yep.
there. In there. They're going to tell us a little bit about Vaya Space, their Dauntless rocket. We've got an engine going behind here on the green screen that's similar to what they're using. Years ago, they were started as rocket crafters, had 3 or 4 of your engineers on before. And the electrical engineers are the same thing that Marty was. Marty Winkel, my co-producer, running the Streamlabs program today. Marty, good to see you. We were wondering what kind of similarities they might be between 50 years ago when Marty worked on the Apollo lunar modules and the Dauntless rocket today. We may talk about some of that. I'm getting my smart tablet up here so we can take your questions, okay? So let me get that set up there. And first, we have a little bit of paperwork to do. Marty, I didn't do the printout, but that's okay. A little off my kilter today. Chuck Jeffrey and his Bid Again auction supports our program. You want to get appraisal of some of your space memorabilia, get a hold of Chuck there. And our next auction is on next Saturday, September 7th. All right, there's the info on Chuck. Chuck at AmericanSpaceMuseum.org, or his phone number there is a Orlando extension. Charity memorabilia auction centered on a lot of artwork and some gold and silver in there. So always fun to watch. We will go through that next week in detail for you all. But you can go now to our website, go to the auction site and start bidding. Of course, we're going to be closed Saturday and Monday, Labor Day, September 2nd. So Saturday we're closed, of course, to honor our fallen executive director, Karen Conklin. Died of cancer, and this is a real tragedy here at our American Space Museum. She's the soul of this museum for 20 some years, executive director the last 6, and we're just going to miss Karen a whole lot. She loved her fur babies there and is just a wonderful, warm person. So those of you in the area, the service is at North Brevard Charity at 2 o'clock, and at the museum we will have a celebration of her life at the request of her husband Mark, and we will be closed though here to the general public. Well, there you are, guys. Is like we like Future Fridays like today, talking about the future, so let's first talk a little bit about each one of you. Start off with Rick. Tell us a little about where you grew up, and Rick's got an extensive 40 years experience in electronics, including working almost 20 years at the Glenn Research Center in Cleveland. So how'd all that happen? What kind of a kid were you?
I was a curious kid.
All right.
I was. I grew up tearing things apart, like most engineers.
Did you put any together?
Eventually.
Yeah.
But you start by tearing things apart to see how things work. And so that's kind of what led me to where I am. So if you're tearing things apart, you're not far wrong.
Good.
Spent
a lot of time in Ohio. Grew up. Where'd you born?
I was born in California.
Mom
and Dad were from Pennsylvania. They went out to California for a while, moved back to Ohio. I don't know how that worked, but I grew up there, and then after high school, went into the Air Force as an avionics engineer or an avionics technician on the F-111 aircraft. Got out of the Air Force after 9 years and started doing more electronics throughout industry, and then got into space up at NASA Glenn Research Center. Worked there for about 19 years. And then in 2020, just before the pandemic, I moved down here to work for Lockheed.
Uh, Rick, people don't think of on the shores of Lake Erie being an important asset to NASA, but it's one of the most important. And over by Sandusky is the big
Vacuum chamber.
yeah, vacuum chamber
Yeah.
up there. So
Yeah, a lot happened in Cleveland for NASA. It's a research center. It's not like one of your regular space centers or your like JPL or anything like that. But we do important research there. It's an aeronautics center. We have a 500-foot zero G pit that we drop experiments into to see how things will react in 0G during that 2-second to 2.2-second drop, so that we know kind of how things are going to react once we take them into space. So,
well, you're quite an asset to Rob Fabian, the leader there, and your group there. Of course, Ohio's a wonderful state to be in from about May to November, maybe late October,
right.
Unless you really love snow, and we know people do love snow and the whole environment there. But you mentioned that your wife was also in the business.
Yeah, she was.
What's her name?
Sue.
Sue.
Yeah.
Sue, glad to see you. As we know, you're watching your husband here.
Yeah, she and I worked for. She worked for a different contractor when I was working for working with NASA, and so I was telling Mark that we are probably one of the few husband and wife teams that had things on the space station at the same time. She wrote procedures and crew-based or computer-based training for the crews while she was there. So
what kind of things you and your wife have on the space station that we would relate to as space geeks?
Okay. I worked on a project called MDCA. It was multi-droplet combustion apparatus. So you've probably seen in some of the videos a black cylinder about this big around that goes into a rack, and sometimes they'll pull the thing out. And what they're doing is what they were doing at that time, and it's been used for because it's multi-user, used for a lot of different experiments. So what they were doing was they were igniting fuel in 0G and then watching it to see how it burns. It's very interesting how things happen in 0G because we don't have natural convection of heat rising or anything like that. So what happens to that flame that's going around a fuel droplet? So it kind of helped inform NASA scientists how fuel burns. So they know how to ignite it, they know how to manage it, they know things like that. Some of the other things that were done on that experiment in that rack were materials, flames. So they'd catch different types of materials on fire to see how flame fronts propagate. So for fire prevention, for fire extinguishing, things like that. That is quite a concern up there. One of the worst things that could happen on space station is a fire because of the way flames propagate.
Great explanation. Marty Winkel on our board here. We just heard Don Thomas out to Space Center in Ohio, that he was asked what he was the most scared of his 4 flights. And Marty, that's coincidence, isn't it? He said coming in, they just fired the engines to slow down and turn the spacecraft around to start the 50-minute glide through the atmosphere. And one of the astronauts said, "I smell smoke." And he said for about 10 seconds, his mind raced to we're going to die. That's the worst thing you want.
Yep.
And but then nobody else smelled the smoke, and apparently wasn't smoke. But yeah, that's so very, very interesting there. Thanks, Rick. Well, you're willing to interject any of that great knowledge you have there and how you're applying it to Vaya Space as we go along here. We'll talk to Josh Dzugen here. Josh, we met you were on the panel for the future at our Shuttle Fest 3 last year, and met your wife up at the Friday meet and greet. Did you have a lot of fun that weekend?
Yes, sir. Thank you. It was a great opportunity. The Shuttle Fest was an amazing event. Best space event I've ever been to. And
Oh, good.
thank you for
Thank you.
thank you for inviting Vaya. It's a great opportunity to show what the future of space is going to be and the capabilities.
For those of you who don't know, our Shuttle Fest 4 will be April 11th and 12th right now at the Hyatt Place Hotel, where the theme is Hubble plus 35 years. Hopefully have a lot of Hubble huggers there, because they didn't get to hug each other the 30th anniversary, because that was during the COVID pandemic. Mm-hmm. We always end Shuttle Fest with a future panel. Pick people to talk about this rocket renaissance that's going on and what the future holds. So we're going to be selling tickets for that starting Sunday. And we have about 125 is the limit of that hotel. If you're on a waiting list, we may move the event to a larger hotel. So got some great intelligent people that are watching the show today as usual, guys. So they may challenge you with some questions, and I hope they do. One of them, Steve Jokums, he said that the Glenn, formerly the Lewis Research Center, never gets the notice that is due. Major contributions there. Would you agree with that?
I would. Yeah. The Glenn Research Center is one of the ones that, well, not a lot of people talk about it, but we do, and we know it.
Yeah, right. Okay.
And
how many employees are there? A couple hundred or 1,000?
It has shrunk. It used to be quite large, within the 8 to 9, 10,000 there, and I think that it's shrunk quite a bit over the years. I think there 2,000. Maybe 2,000 government employees, and then the contractors.
Oh, that's pretty big.
So, it's
you gotta think how big the parking lot is. So
yeah,
get everybody in there.
Yeah.
Well, great. We got Tom UCX watching. Hello. Have a safe and enjoyable holiday weekend. And yep, it's going to be a tough one, Tommy. I'm pretty emotional today about Karen's funeral tomorrow and all the preparation we've had to have to do. Doug Forrest is in Los Angeles watching us. Carlton Bailey says hello to everybody. He's in Canaveral Groves. He can't wait to hear the rocket go off from his backyard there when you guys start testing there. So, and of course, he's sending his condolences to the family, and Karen's service will be live, we believe, on the funeral home feed there. So, well, let's talk about Vaya Space here. I didn't have my slides racked up. There you are at our Shuttle Fest, Josh, on our future panel there. You did a great job. There's the Vaya logo. What's the hidden, the V? We're going to talk about why it's Vaya here in a minute. Dauntless is their rocket. And you have different configurations, right? With different core stages.
Yes. This is what we're looking at here is the Dauntless 1, which is a 2-stage rocket, 6 engines for stage 1, and a single engine for stage 2. And we're looking with the Block 1, which is what this is, I think maybe 500 to 750 kilogram load capacity.
Okay. 500 to so that's, you're talking what, 1 ton
to about a ton and a half.
Yeah, about a ton and a half on there to low Earth orbit. Talking 100 to 200 miles high, right? Is that what we're defining low Earth orbit as?
I think so.
Somewhere around in there. We had some of your mates on here. We just wanted to say we had Keith and Giovanni on here. They were really great on there. Giovanni is your ignition guy, isn't he?
Right. He does.
He was talking about how they're igniting. I'm going to have Josh talk here in a minute about what Vaya Space is all about with their reusable fuels. David Maley was on here, and you said David's gone to another company in a friendly way, which is sort of the landscape, I would think, of the industry as other opportunities come up. And Marty, we had these delightful ladies on here, Catherine and Michaela. They got a picture with Jay Honeycutt was here, the great director at the Space Center
okay.
and Shuttle Brain on there. So we're glad that they were on to share. So just go on to YouTube and put Vaya Space in there, and you can learn a lot more from these propulsion engineer and a systems engineer there. There's your headquarters location. Just we're only 50 minutes from Orlando. In that area, you've got, of course, notable people on your board of directors there, but none more standing out more than your chairman of the board, Sid Gutierrez, former astronaut, commander of a shuttle, NASA's first Hispanic astronaut, and launch director Bob Seek said to Sid as they launched, Vaya con Dios, which is the traditional Godspeed in Hispanic, and that's where you get Vaya, right?
That's where we get Vaya.
That's where we get Vaya.
In there. So you all met Sid?
Oh yeah.
Yeah. Everyone says, "Oh yeah." He's I've not met him there yet, and keep telling Ron Fabian, your boss, hey, when Sid comes to town, we'd like to get him on here. But, I understand he's a really great guy and has a great interest in this company.
Mm-hmm.
In there.
Yep.
You got anything to say about Sid?
Oh, Sid's a great guy. There's just so many good things to say about him.
You know,
He's super down to earth. He'll tell you anything you want to know.
Well, what's it like having somebody like that having your back and encouraging you as a mentor and coach, so to speak?
You know, some of the most, honestly, and I don't mean this like in a funny way, but the most down-to-earth people that I've met have been astronauts.
Mm-hmm.
You know,
Uh-huh.
they'll talk. They're just like, I worked at a company in Cleveland, and Guy Bluford was one of our top executives.
Oh,
And
wow.
he and I sat and talked for 20 minutes, and he told me all about, his experiences as a commander, the first
African American
to go to space.
Launched today, by the way, in
Mhm.
space history.
Mhm.
I think 1983, if I'm not mistaken, is STS-8. I have here, guys, the shuttle scroll. It's our official scroll here. And though I don't have my glasses on, STS-8 was yesterday, 8:30, with Truly and Bluford and all that.
Mhm.
So that's great guy going to space. That's very interesting. Yeah, to say a lot of astronauts are down to earth, that pun is. Marty and I've met a lot of them. We go out to the Space Center and get the autographs and get to meet them. And of course, we have an ulterior motive. We want them to understand that our museum loves them and wants to honor them. And the shuttle era has over 300 astronauts out there in America. There's only 617 humans have orbited the Earth in all eternity. Just 617. I mean, I'm a baby boomer. I thought after the Apollo landings 50 years ago, there'd be 6,000 people
right?
that could say they've been to space now. But I guess it shows how hard it is, huh, Josh?
Oh, it's hard going to space.
Yeah. What have been the challenges? First, let's get back to learn a little about these guys here. We're talking to two electrical engineers for Vaya Space. Josh, where'd you grow up, and how'd you get hooked on wanting to build rockets?
So I was born in Tampa and then moved about an hour north of there in Brooksville. Went to a small private school there, and then moved over here for college at Florida Tech, and then transferred out to FIU to finish my degree. And watching my brother go through school, he's a mechanical engineer. He works out at the Space Center.
Mm-hmm.
Got me into engineering. Growing up, same as Rick, I was just tinkering, taking apart remote controls, trying to put them back together. Maybe they worked, maybe they didn't. Maybe got in trouble a little bit.
Yeah.
But it's just going through school, and then you find your niche. Electricity is one of those things like you can't touch, and it's very challenging. So I wanted to push myself into that field.
Uh-huh.
And there's so many aspects from RF communication to circuit board design where you can really hone your skills in it.
Well, I consider myself pretty educated, but I do fear electricity. I don't understand electricity, and I don't understand how those big ships can float. out there at the port, okay, that are like 5 stories tall. But it's what's it like working at Vaya Space with someone experienced like Rick there with you?
Rick's been an amazing mentor. I take everything he tells me and I store it in my brain because I know one day it'll come back and I'll be like, Rick told me how to do this. He's been amazing. I take everything he takes.
Good, good, good. Tell us a little bit about where. Let's see, what next picture do I have here? Josh, tell us a little bit about the company line of this. Why is this company different? With eco-friendly, safe, reliable, reusable. What's the company pitch there for us, please?
So our rocket fuel is a hybrid engine. So most of it is made out of recycled plastics, so bottle caps.
The top of the cap, I understand, right?
Yes, sir.
Not
Yes,
the
sir.
bottle, but they want
The hard to
but
recycle.
the hard
plastic.
is what you guys recycle there, and that's a special type of plastic that you can use for rocket fuel, huh?
Mm-hmm.
Yes, sir. And it gives us a very safe vehicle, only having some kind of oxidizer with a plastic fuel because plastic is non-explosive, and you can touch it, you can store it. It's very storable. It has a lot of purposes, and it's very easy to manufacture in a way, and scalability is big with us. So, and once we get our technology down, the rapid production of them.
So they're using site recyclable materials. It's green in other ways with the 3D printing and so forth in there. We have two of the rocket engines actually in our conference room that we were going to have someday we'll have some sort of display here with your stuff. But it's rocket fuel in our building, and there's no safety at all. It's just a hunk of plastic laying there.
I was going to ask you, how many other hybrid engines or solid rocket fuel engines do you have in your building?
Right, none, and it's completely safe. For example, the solid rocket boosters of the now air SLS system in the VAB, because they're there, people don't have access to the Columbia gallery of the remains of the Columbia spacecraft, and they're thinking about moving some of that where more people can get access because you got a hazard there with something explosive in there. So, yeah, Marty, go ahead and give us that question on the UCX family microphone there.
I'm assuming that, are you really using bottle caps, or is there a manufacturing process that creates that same plastic material? Or are you actually using bottle caps? If you are using bottle caps, how many bottle caps do you need for, let's say, X number of pounds of thrust?
What we're looking at is about 20 million pounds?
It's like
20 tons.
20 metric tons of plastic.
That we're taking into space with us.
But do you actually harvest the bottle caps from some recycling plant?
We have a manufacturer. I'm not certain of how they're what they're using to recycle, but we get the pellets. We actually get pellets of this. It's called HDPE. It's high density polyethylene, and we get these pellets, and they go through our 3D printer, through a hopper. They melt, and get spun into these motors. Interestingly, like Josh said, is that that we are scalable. So we have very small rockets that we can use for test. By scaling down the fluids and everything, we can do our burn tests with it, knowing that by scaling things up, we're going to have we can get higher thrusts and everything. We also have recently been touted a little bit by the defense industry, defense department, to start looking at some. They're interested in our rocket technology for some of their missile technology and and things like this. So we are going places. We are reaching out there.
You had an important test, I know, in front of some military VIPs. It was on your Facebook page.
Yes.
Marty, I think I did print out our script.
I looked.
I think it's laying there on the printer.
Yeah,
Yep, on the other side. I'm reusing old prints there, so thank you. As you see here, we're a real professional operation here. We wear everything warts and all here. But well, that of course, Rob Fabian, your president of the company. I know Rob very well and through business, and he worked for the MX missile system,
Mm-hmm.
the
Yeah.
underground missiles that were all over our fruited plain out there. He was involved with that.
Yep.
So he definitely has some great military connections with the company
Mm-hmm.
in there. So that's a logical step
Yep.
there. And of course, that's I think personally that's what's going to happen to Elon Musk's Starship, is if he gets it very successful. Gee, we can put 50 Marines in there, a couple helicopters, a Jeep, and a anti-aircraft missile or two,
Yep.
and be in Russia in 45 minutes. Am I right? Is this how some things go?
It is how some things go.
Yeah.
It's we prove ourselves through our innovation, and then if people take notice, it's not always a bad thing. So we as Vaya are hoping that people will take notice, because it helps us as investors see that that DoD is taking notice of us, and maybe they want to get a little bit involved in that. So
There you go. Yeah. I know your investor guy, Sean Mursky, he made the news. What did he do? He saved a dog, or
his dog
saved
saved.
his dog
Yes.
saved a neighbor's house fire or something.
Yeah, rescued a woman
Yeah,
out
we
of a
saw.
fire. Yeah.
Sean's a great guy, and it takes a lot of money to keep these startups, and there's a lot of competition. Okay, but make no bones about it. This is a company that has a solid mission and a solid plan. There's we'll talk. What impresses me, though, you're probably how far away are you? You think from really suborbital your first payload in orbit, and not to put you on the spot, but to give a.
So the plan is for first launch is 2026, I believe.
Yeah.
Okay.
And
2026.
that'll be the first payload in orbit. Will be on our first launch.
So that'll put this whole thing 5 to 7 years in development for sure, in there, which it takes that amount of time.
It does.
And you've got a core of you got 50 so employees there, something like that.
Yep.
I've been to your facility there. It's a unique, again, rocket renaissance, very casual. Some people bring their dogs with them.
Oh yeah.
Pet
Yeah.
friendly. You got a pool table to relax with, ping pong, stuff like that. That a baby boomer like me wishes we could work like that, Marty, back in the day. But it's a very new age type of situation there. Lends itself to good harmony among everybody, Josh.
Yes, sir. Yeah, we're a very tight knit family. Everybody knows everybody. We all get along. If you need help, just everybody's accepting of your opinion as well.
Yeah, I liked it that there's no cubicles per se. The walls are down on their little work areas there, and I certainly worked in an era where everybody was in their own cubicle, feeling like they were in their own office. Maybe that was like for you up in Cleveland.
Yeah.
And the only thing. I mean, when you're talking on the phone, that's good,
Right.
and not everyone's hearing all your conversations and stuff. But very, very unique. What do you say about the environment there?
Well, I think that the environment's great. Having been to a bunch of different places, I really love the camaraderie and the easygoingness of Vaya. There are a lot more employees there that are closer to Josh's age than my age.
Yeah, that's why I teased you when he said his headshot. I said, "Oh, you're an old dude." I was expecting another 25-year-old whiz kid to walk in here,
No.
like this young man here.
Yeah.
So,
Yeah, Josh and I actually started on the same day.
oh, really? Okay.
Yep.
Yep.
And but we everybody there gets along. It's interesting because we had a meeting today, and I could walk up to Rob and a one of our propulsions people and bring up a question. I said, first of all, this is completely out of my wheelhouse. I'm not a propulsions person, but what if this? And they were very accepting of that. You know, it wasn't like, you know, go back to your corner, go chase your electrons. You know, it was, and that's just how it is there. If you're walking down the hall and you hear a conversation, you can just walk into it and you can talk to people and ask questions or redirect a thought, you know, which is how we engineer. That's how we learn.
I was going to say it's like a working think tank, a practical think tank where you need a lot of creative minds because you are going into an unknown area.
Yep.
There are a lot of companies that are vying for this low Earth orbit payload where, what are we talking about? We're talking about FIT, Florida Institute of Technology, wanting to put a 300-pound something up there to do something, and at $10,000 a pound, you know, you all are competing with other people to do that.
Right.
But from talking to your boss Rob and other people, wow, there's people lined up. You already have a manifest of business.
Yes.
Ready to roll.
Yeah. We just got a contractor that is looking at, can't remember how many hundred satellites that they're already, you know, early committing to work with us. So, I mean, that's, I think they said 20 or 30 flights for us that are going to get, you know, that are going to go on our books before we're ready to go. So
we're going to see where all this is launched. Let's just a minute and get an idea how many you might be able to launch in a year from our Florida Space Coast. Here's another schematic of the Dauntless rocket. I've been taking stuff off your Facebook page, your website, and of course this is a private company, so they don't let all the goodies out there, you know, because you're in competition. But just basically, we're looking at the 3-stager here. Your Block 2 vehicle is that still the 2?
That's a 3-stage vehicle.
is that a thing?
Okay. Josh, what are we looking at here?
So that is looks to be a 3-stage vehicle there. But our original Block 1, that's our Block 2 vehicle. Our Block 1 vehicle will be the same configuration without that second stage in there. It'll be a fully autonomous vehicle, so once it leaves the ground, it'll be flying on its own.
Yeah, we're going to talk about that in a minute. About how tall?
About 65 feet tall.
Okay, 65 feet tall.
And the first stage will be about 6 feet in diameter with the engine pods attached, I believe.
Of course, fairings are an important part of any rocket to shield the payload up there.
Right.
You all creating your own fairing?
Not for these first few launches.
Okay. There's
We
some
may
company out
at
there
some point, but
specializing in that.
yes.
We got a couple questions here. Dean Babcock, one of our wonderful viewers, says, what makes the plastic bottle caps so suitable for use as a fuel?
I don't know the chemistry of it, but what I do understand is that it is that as it's burning, because of the way it's burning with a liquid oxygen as its oxidizer, it burns very cleanly. So we have very little residue compared to other fuels that are out there. A lot of our residue is water. We have water. We have some carbon monoxide, I think, is some of it, and then there are very little other residues. So that's one thing that makes it happen. And then under the high pressure liquid oxygen, it burns very well. Almost complete. I mean, it burns completely. if you see some of our the shells of some of the engines that we've burned, there's nothing left from the center.
And it's a clean, even burn the whole way through.
Mm-hmm.
Is it hollow inside to configure the burn like the solid rocket boosters are?
We don't need to do that because we can throttle. We have that the advantage of throttling the oxidizer through the cavity of our fuel grain, so that like a solid rocket, you have to know the profile of the burn before you create the rocket.
Mm-hmm.
And with ours, we can throttle that rocket, which gives us a lot of, and we can relight the rocket after it begins to burn, which you can't do with a solid
That's
solid
very
rocket.
important. And throttling ability and turn off and on.
Yeah.
So you could actually turn off and on a second stage.
Yes.
Important to go to a geosynchronous orbit or a specific spot
Exactly.
that the military might want to look at.
That is
right
what they're
away.
talking to us about. Yeah.
Yeah, that's what it was. Your test was that you showed the throttle ability of it, I
Mhm.
believe, in there.
Yep.
Josh, speak about the stages that are involved here. You just don't jump on a rocket. There's so many things to do, and so you're doing things electronically. How does that advance down the management timeline to
Where to begin? So it begins in sourcing. What do you need? What do we need to come to bring this whole vehicle together? For us, you treat this vehicle like a human body. We're the nervous system. We're the heart of the vehicle.
Okay.
So we make the vehicle work and talk. So we connect everything to make all the controls move and talk together. From there, once we have our part list done and our design work done, we go into testing from there.
Okay.
So,
Well, how's it going to launch? We off camera we talked a little bit about that. I want you to share about the new age of electrical engineers. You don't have a bunch of wires connected to the side of it that are going to have to be pulled off, do you, when it launches?
so we still have umbilicals, but it won't be these giant umbilicals, hopefully, that other companies have. We'll have, just a power umbilical to charge, batteries onboard power, and a communication umbilical. So just two small umbilicals going into the vehicle. Most of the vehicles now we can command or get signal on and off the vehicle just over Ethernet or over fiber. So it's a lot faster, a lot smoother process now.
So you're launching wireless
In some aspects it is wireless, because once the vehicle launches off the pad, it'll be downlinked straight to a ground site and then just piped right over to our command center.
Okay. And are you involved in, of course, there's got to have some computer power on there to control everything.
Right. Yeah.
Rick. So
Yep. We have a flight computer, and a stage controller.
and throw a computer geek thing out there to computer people. What kind of computers on there?
Oh, okay. We're using a company called UEI, United Electronic Industries. They are also, UEI also does a lot of the ground support things out at Pad 39. So they've been around for a while. They are our brain for that. We're running a VxWorks engine using the Core Flight software. NASA's Core Flight software is our protocol that we're using for writing our control software. I work closely with the GNC, Guidance, Navigation, and Control people, who are writing the control algorithms for the computer, using an inertial measurement unit and some GPS, so that we know where we are and where we need to go. Right now they're writing all of the what's called 6 DOF, which is 6 degrees of freedom algorithms for this rocket that will be the basis for our control algorithms.
Okay. Is it compared to like I've got my business desktop over there. I got this computer in here. But what kind of computer power is it?
You know what? It's not much more than if that. I mean, some of the computers that we have for designing our rocket has a lot more power than the flight computer itself is going to have.
Okay.
It's all in the management of that memory that you have. I mean, we know that the Apollo rocket and the AGC and the flight computer and everything was very limited compared to today's computers, and they did a lot because they managed the systems well.
Mm-hmm.
You know, so we have a lot more power than they did, and we're not doing nearly as much as as they did. But it's just in how we're going to manage our data.
We're going to look at the launch sites here, but electrical engineers, I've read things down the line where electrical things could be replaced with fluid dynamics and so forth. Are you familiar with that? Is there any new technology on this Dauntless that we would be surprised about? But that fluid thing was interesting to me because it was a real big deal back in the 80s, I think.
Okay, as far as how to equate it, how to make things work the same. Yeah, I used to teach at a community college, and some of the best ways that I could get that across to new students was to talk about the plumbing in their house, because you have voltage, which is basically a pump. It's the pressure. It's a pump, right, in the line. Then you have current, which is the pressures running through the line. You have resistors, which is where your pipes get smaller or fatter, so you have a faster or slower flow. So you can equate a lot of what we do in electronics to fluid flow.
Oh, that's interesting.
So it's kind of an interesting way to think about. You say that you don't understand electrons or electronics. Well, if you understand some plumbing and some hydraulic type systems, then you're not too far off from understanding the physics of electronics.
That's a good way to put it. In a general way, I was talking about that they were looking at, there's ways to use fluid to actuate airplane things and stuff like that instead of using electrons.
Oh, okay.
Yeah.
Yeah. So instead of
That's
using
it.
motors, using more of a hydraulic type
right in there.
system. Yeah.
But I was glad that you equated it like that.
Yeah.
on that,
Sorry.
so. No, not at all. Not at all. I was reaching there to just sort of figure out, is there something on this, proprietary that you could share with us? Launching with Vaya, of course, the all the good things that every company's saying out there that they're going to do, but what separates you all from the pack, do you think?
The safety of the vehicle.
Right. Exactly. We are working to get a zero explosive, zero TNT equivalents on our rockets, on our engines, which makes us super safe. As a matter of fact, Josh is working on our flight termination system, and you've seen flight termination systems.
Yeah, I was just going to say, what about pyrotechnics?
We do not have pyrotechnics on our vehicle.
But you have a termination system in case it starts going to Orlando. You're going to blow it up over Cocoa.
We're not going to blow it up.
Oh, really?
We do thrust termination. We shut off the oxidizer, and it just falls to the ground. And because that way we don't have to worry about a debris field, which causes another problem.
True.
How things are going to fall apart. We don't have to do that. And by the same token, our stage separation, instead of using pyrotechnics for that, we're using pneumatic push-offs for our stage separation. So we're not even nowhere on the.
Yeah, I was going to
rocket.
ask about stage separation. So you're using pneumatic pull-offs. What's that, Josh?
It's a bunch of pneumatic rods which just push one stage off of the other one, and you just let gravity kind of take place, and they fall from each other.
It's like a
Triggered by electronic.
the electronics will release it.
actuators.
Yep. Open a circuit, and the spring will release, and the rod will push the stages apart.
Is SpaceX using some magnetic systems with some of their stage separations, or am I wrong?
I'm
about
not
that?
certain. I'm not certain
Okay.
what
Would that work? A magnetic force field?
I don't know that
for-
you'd have the strength that you would need, the forces involved. But then again, I don't know. That you can make some pretty strong magnets. So I really don't.
Okay,
Don't
we're
know.
reaching out there. We're enjoying this conversation with Rick Powis and Josh Dzugen here. They're electrical engineers at our local rocket company, Vaya Space. There is your CE, your president there, Rob, on the right, with the Phantom president shaking hands. Why?
We're actually sharing LC-13 together. We'll be sharing as a joint launch pad.
Right above Rick's head there is LC-13. That's landing zone 1 and 2. We can see him there famously for the SpaceX Falcon 9 rocket. There they are with the SpaceX logo on them. Pretty cool to see those Falcon Heavy boosters come back. I know you guys have enjoyed that a few times. And hopefully we'll have that again by the end of the month. There's I think it's Kepler, ESA probe that's going to be launched. So they're going to have to move.
Yeah,
Yep.
yeah. I went out early this year to look at that, to do a first-time survey on that site, just to figure out what they were going to be leaving us and what they were taking with them. And
how's that cooperation?
oh, it's good. It's good. Yeah, it's a good cooperation. It's not like there's no animosity or anything there.
Well, where are they going to land?
What site did they get? Do you know? I don't know.
I don't think they've got another one yet.
Okay.
I believe Kennedy Space Center wants them required that where you launched, you
You have to
land.
land.
That's what it is. That's
Because
what it
of the there's so much. This is now real estate out there, fans. It's like a real estate agent selling these rocket pads out there, right?
Yep.
And they have a price and a lease agreement, and probably who's going to mow the yard and all that stuff around it.
Yep. Yep.
Well, I mean, what do you know about that? What's that like, Josh? You know anything about that?
I don't deal with that side
Yeah.
of contracting, so I can't speak to that.
What was your feeling going out there? This is a historic pad.
That was my first thought. That this was okay. So it's SpaceX. That's cool, but this is history, and I've been out there before and got to look at the different pads. One of the most surreal places to be is out where Apollo 1
Oh yeah,
happened.
pad 34.
Pad 34, where that happened, and the memorial there. It's a very surreal place. If you ever get a chance to go out there, do. And but it's just as fun to go to some of the very early launch sites out there. Now, pad 13 and 14, or pad 13 is very interesting because it is a double pad, and they do have all of the utilities, a lot of the utilities that are run in there already for us. So that's kind of what we are negotiating with Space Force to see what more they're going to have for us. If they're going to have water, do we need to, truck our own water, and do they have, how is all this going to work?
Yes, I said Cape Kennedy, but it's actually the Space Force that is the pad here. Well, there we go. That's Space Force territory there. So that's interesting, and I'm glad that y'all could share that with us today on there. Carlton Bailey, one of our fans, and he's photographed over 700 rocket launches, and I'm sure he will like to photograph yours. Lives out there, Canaveral Groves, and he's saying, "Is that your generator noise every night east of my house?" Now, your there isn't any noise, is there?
No, we don't have
No.
anything. We don't have
Okay.
anything right now.
Your test stand pad is over by the cement factory, correct?
Right. Yep.
Those of you that know the area there, and Rob told me that you were getting all the permits and everything, and have had the hearings and all that sort of stuff.
Yep.
So,
Yep.
so how soon from now are you going to be waking me up in the middle of the night? Because we want to hear it.
Oh yeah, yeah. So do we.
Yeah.
This is for our orbital engine, which is
Uh-huh.
the largest engines that we're building right now. The test stand for that, and we will. The plan is end of November,
Correct.
I think, is
Oh, wow.
when we're hoping to have our first.
Would there be a
Firing
public awareness of this?
I
Just
would
FYI,
imagine that it
I don't-
might be pushed out there just so that people know it's
Yeah.
coming.
Well,
One thing.
friendly neighbors, and I was
Oh yeah,
understanding
right.
that you know that no, you want people to know you're doing this test and so forth.
Right. Yeah.
And I mean, this is very historic. It's a private company that right here where the birthplace of the space age here in Brevard County, and it's going to be a big deal there. Dean Babcock, Marty, I see that question from Dean. You want to go ahead and ask it?
Yeah, Dean's asking, where will the rockets be assembled?
Right now, we are looking at our own facility there in Cocoa
Okay.
for doing it. We're hoping to get moved into another facility before too long. The number of launches that we're planning on doing after our first one, we're going to build up to where we're hoping to do 40 to 50 launches a year.
40 to 50 a year. That's what I wanted to hear. Wow.
Yes.
That's one a week.
Yes.
I mean,
Yeah.
one every 10 days, let's say, basically.
Yep.
In there.
That's our plan.
That's a whole other crew of employees, right?
Yeah.
Probably premature to start training them now, or you got that in the queue?
Not in the queue yet. Our production people are planning. They have plans in place for when they're going to start doing that, but that's going to come down a little bit later. And then right now, Josh and I, being the electrical team, are going to be involved in the early launches and the early production phases. But later on, I imagine that we will be in the design phases for the new blocks that are coming out, and we'll have a whole new team of electrical engineers that are doing just production.
Well, having followed Vaya Space now for a couple years, 3 years or so, I could see things are going to start happening real quickly around there as things are pulling together. Someone might ask, why does it take so long? From drawing board, dauntless idea to the first launch is going to take, almost 10 years.
A lot of it is regulatory. A lot of it is
Regulatory.
Regulatory. Yep. The launch licenses that we have to do, getting the our flight
FAA
plans, our
license,
FAA
all that
licenses,
stuff.
getting our flight plans approved. Like I was talking about GNC before, they have to come up with a flight plan for a given mission, and then that has to go through an approval process before we can even start doing that. The testing is huge. As the electrical engineers, nearly every component that we have has to go through a testing program, particularly for the flight termination system, because they want to make sure that if there is a problem, this flight is going to terminate.
And that's your baby, right?
Yes, sir. That's my baby. And then every plan you write or every test you do, you have to submit before you can do the test and wait for their approval to do it. So it's a very lengthy process.
And that's on top of the design, which is the other, the design work is something, because at Vaya, what we're doing is a lot of our components are bespoke, because it's too expensive to go out there and buy some of the equipment, or there just isn't equipment that you need. Power distribution unit, you know, they are particular to our rocket because of the type of systems that we have. Batteries, flight batteries are very expensive. You can go to different companies and you can find them, but they're very expensive. So we're looking at designing our own in-house avionics batteries. So this puts some time on it too. Now then that has to go through testing. So
Did you see the batteries in our Cape Canaveral gallery up there? We have one of the first NiCad batteries from France. And there was batteries with fluids in them too.
Oh,
you
yeah.
know, up in there.
Mm-hmm.
We'll go back and show you there. Well, I've enjoyed talking to you gentlemen here, and they're very fascinating. This is you can multiply this a few times out there in the landscape of other companies that are doing it. Like your partner sharing the launch pad. What are they going to launch specifically?
I don't even know.
Oh, you don't even know?
No, I don't know what their plans are for launch. Rob may have talked to them, but I have not been given any of that information.
Well, it'll be interesting how the payloads sort of spread out. You know, maybe I don't know. How do you think that might work out? In other words, I'm thinking like, wow, will you get a bunch of university contracts, for example, or will you get commercial? I see some of these new rocket renaissance companies wanting to go to the commercial industry. Maybe some people would just be strictly pharmaceutical. Is that how it's going to end up, you think?
Well, the small satellite niche, I should say, is very large for people that are looking to launch small satellites. And there are very few companies that are doing that the way that we are. One thing that makes Vaya and our small launch vehicles very viable is that we can, because we're putting up small payloads, we can put them into a specific orbit that you want. You know, if you go with SpaceX, it's the thing I was early on said, it's like getting on a bus. If you get on a bus, it's going to take you to where it's going. It's not going to take you to necessarily where you want to go. If you want to go where you want to go, you're going to get on take an Uber.
Yeah.
And so we are like the Uber of small satellites.
Great question from Carlton Bailey. Expendable or recoverable rockets?
Not yet. They are not yet recoverable. There has been some talk that when we start launching as many as we want to eventually, that we'll start doing some kind of recovery with them. But right now they are expendable.
What y'all think about 237 landings in 237 to 1? I mean, for SpaceX.
Yeah.
I mean,
Yeah. It's an impressive record.
It is.
First of all, it's an impressive record. And, you know, it's interesting to watch live on there, and then you have the people as it's starting to fall over go, no, because they don't expect it. You know, it's just it's always worked that way.
I think most of us have watched these noisy rockets in the middle of the night, waking up our dogs. Really enjoyed watching the landing on the view as much as possible, because you never know. It's really amazing. Who would have thunk it, type of thing. that the way things are going on here. Guys, I've really enjoyed it. Marty, do you have anything else to ask these gentlemen?
I was just asking, or thinking. I think one of your compadres that we talked to previously said your engines are not gimbaled, that you're using little thrusters on the engine. Is that correct?
For
way off.
For our stage, stage 2, we will have they will be gimbaled, but we are using a RCS system for orienting the rocket as well.
What's the fuel for the RCS system? Do you know?
Not yet.
Oh.
I'm waiting for some information on that
But that includes electronics.
I'm writing. I'm taking care of the control system for that. So I'm like, let me know.
Oh, okay.
Let me know what you need controlled.
Well, terrific. Is there something I didn't ask you, Josh, or that you'd like to share about Vaya Space or the job you're doing?
I just like to tell a lot of the younger people out there, make your job your passion. So when you get up every day, it's not like you're going to work. You're going on a field trip. You don't regret getting up every day. So that's just what I like to tell everybody.
That's good. That's good. That's good. You feel you got a long future at Vaya?
Yes, sir. Yes, sir. It's a great company. I love it there.
Good. Anything I didn't ask you, Rick? I've enjoyed what you've shared, as everybody else has.
Thank you for having us. No, the only thing I can say is that I envy Josh. I tell him this because I'm coming near the end of my career,
Right.
and he's starting his, and I just see a lot of really cool things that can happen in the next 40 years or so that he's doing this.
And somebody on the ball like he is, obviously will become desirable to some other company down the line if you don't. So you use that as a bargaining tool
That's right.
with the boss out there, okay, in there. But no, it's this is what has brought back the entire Space Coast. I've lived here now over 7 years, and it's unbelievable in the last 5 years how the streets look cleaner, and I mean that things just look a little more buffed up a little bit, all because of SpaceX.
Yep.
Bringing in this Falcon 9 rocket. That I was reading a story last night that they think this Falcon 9 rocket will go into the 2040s as still as a viable rocket,
Sure.
as efficient as it is.
Yep.
$60 million a launch is about that figure I see all the time on there. Yours will probably be a lot lower than that, of course. But Marty, yes.
I got a question. It might be like a silly question, but do you all do recycling of bottle caps? So do you want this one I have?
Yeah, I have one. We'll start saving them for you here at the American Space Museum. Yes.
We'll throw them into our hopper.
There you go. There you go. Well, Rick, my pleasure to meet
Nice
you.
meeting you.
Josh, you guys don't be a
Good to see
stranger
you.
to the American Space Museum.
Nope.
We've always told Mary Baldino, your wonderful PR lady, that we welcome a Vaya night down here sometime. We'd like to have you all down here, employees, and cook some burgers and have some adult beverages and maybe look through a telescope this fall. So,
Yeah. Oh, I'm supposed to say that Mary is the best too.
Oh yeah, Mary is the best.
Mary is the best.
he said, "Good."
So
Mary is the best.
She wanted me.
Oh,
No,
wanted
no,
you to say that?
She didn't want me to say.
Okay, no.
That was totally on me.
Well, it is a great family atmosphere there. I enjoyed every time I go there, trying to get a Legends of NASA tour there to some of these old timers to see how your operation is such an open, friendly environment like a lot of businesses are today. So, Marty, thank you for a great week on Streamlabs here. Those of you wondering, our intern Logan Cope has some scheduling conflicts at the afternoon, but he hopefully will be back to help us. In the meantime, we've got about 1,125 episodes of Stay Curious in the books, and we will be closed at the museum tomorrow. We want to remind everybody again about Karen. You can watch her funeral service online, North Brevard Funeral Home there. So we will pay our respects to her. It's been very difficult and hard for our staff here to lose somebody so quick that was such a force of nature in the space community like Karen was. So God bless her and her family, and we'll put those good. So anyway, thank you all for a great program. Thank you all for watching. And until next time, I'm Marquette saying I can't wait to see you in our museum to bridge the space between us.